Hello and welcome to this video on ratios and proportions in practical situations. This is the next video in our series of functional skills maths videos at levels 1 and 2. The learning outcome for this video is to identify ratios and proportions in practical contexts and solve practical problems. The linked learning goes back to the previous lesson where we learned about ratios and totals and parts type ratios. So just to jog your memory, there was Pete's famous cake of flour and sugar in the ratio of 3:2. And if the cake weighed 100 grams, which was a total, then we would divide it by the total number of parts to work out what we called our scale. We went back and multiplied each side by that scale of 20 to give us how much of each ingredient we required. And this was what we called a totals ratio. The other type, when we had Pete's famous cake, was a parts ratio. And on this ratio, I would tell you a specific amount of one of the two ingredients. So if I said I had 80 grams of sugar, the 80 went here. And this time, to find our scale, we divide the 80 by the 2 to give us our scale of 40. So 2 times 40 gave us our 80. What you do to one side, you do to the other, and that gives you 120 grams of flour would be needed if you had 80 grams of sugar. Now, one of the things we can do with ratios is we can force one of our two parts to be the number 1. And sometimes it's useful to do this because it allows us to do calculations more easily. However, when you do this and you force one of the sides to be the number 1, the other side generally will be a nasty number. It will be a fraction or a decimal of an amount. However, this is a really useful process, and you come across them in all walks of life. Can you think about where you come across a ratio where one of the numbers is the number 1? Here are a few examples that I came up with. Now, one of them is exchange rates. So when you're going abroad, you might have an exchange rate of £1 to $1.39. Another place you come across them is when you go to Sainsbury's. Whenever you look at the labels for products, you have an amount per kilogram, £1.32 per kilogram. Somewhere that most of you should have seen is when you're driving a car, either miles per hour, so that's per 1 hour, or miles per gallon, so the gallons is the number 1. Now, our unitary method allows us to utilize this number 1. So sometimes you're given the number 1. In other instances, you have to find the number 1. So let's have an example where we're given the number 1 for one of our two values, one of our two parts. Pete is off on holiday to the United States next week. The exchange rate is pounds to dollars, and it's £1 to $1.25. So you can see here that one of my two ratio parts is the number 1. I've forced it to be the number 1, and it's given me this decimal on the other side. Now, if I have £400 that I want to change into dollars, how many dollars will I get? Well, the £400 lives under the pound symbol. So I've gone from 1 to 400. It's a parts ratio, isn't it? I'm giving you one of the two things that we've got on our strap line. So how did I get to 1 to 400? I've multiplied by 400. And when I multiply the other side by 400, I get $500. So that's using the unitary method where you're given the value of 1 as one of your two parts. Now let us look at Best Buy. So this is another way of using the unitary method, and it's probably the most common way that we use unitary method, and we force one of our values to be the number 1. This allows us to compare like with like. So let's have a look at what they do in the supermarkets. Tesco stocks 3 sizes of strawberry jam. The large weighs 500 grams and costs £1. The medium 280 grams and costs 70 pence, and the small jar is 100 grams and costs 50 pence. Which represents the best value for money? And what Tesco will normally do, will write this calculation we're about to do underneath the price of the jam. So let's look at the large. There's a relationship between grams and pounds. Now the other two are in pence, so let's turn this into pence so they're all in pence. So we have a certain amount of grams and it costs a certain number of pence. So the large jar is 500 grams and it costs 100 pence. Now, if I want to know how much 1 penny buys me, I'm going to force this right hand side, the pennies, to be the number 1. So it's going to tell me how many grams I get per penny. Now, how did I get from 100 to the number 1? Well, I divided 100 by itself, and what we already know about division allows us to do that. So 100 divided by 100 gives me 1. Now, when I divide the other side by 100, what you do to one side, you do to the other. 500 divided by 100 gives me 5 grams. So it's telling me my large jar, I get 5 grams for my 1 penny. Let's do the same for the medium jar then. We've got a relationship between grams and pennies, and it's 280 grams for 70 pence. I'm going to force the pennies to be the number 1 by dividing by 70. 70 divided by 70 gives me 1. What I do on one side, I do on the other. So 280 divided by 70 is 4. So the medium jar is telling me that I get 4 grams of jam for my 1 penny. And then finally, our small jar. Our small jar again has a relationship between grams and pence, and this time it's 100 grams to 50 pence. I want to compare like with like, so I'm going to see how much a small jar costs me for just 1 penny. How much jam do I get for my 1 penny? So to go from 50 to 1, I've divided by 50. What I do on one side, I do on the other, and it's telling me the small jar I get 2 grams for my 1 penny. So you can see like with like. My big jar is giving me 5 grams for my penny, my medium jar is 4 grams for my penny, and my small jar is 2 grams for my penny. So the best value for money is the large jar. Have a go at doing this one, comparing like with like. So we've got a small bar of chocolate that weighs 50 grams and costs 25 pence. And then we've got a large bar which is 240 grams and costs 80 pence. To look at the value for money, we need to compare like with like. So for the small bar of chocolate, we've got a relationship between grams and pence. And it's 50 grams is 25 pence. So if I divide by 25, it tells me how much of my chocolate I get for a penny. So when I divide this side by 25, it tells me that I'm getting 2 grams of chocolate for a penny. When I do the same with the large bar of chocolate, and I've got this relationship between grams and pence. I've got 240 grams and it costs me 80 pence. I divide the number of pence by itself to give me 1 pence. So I'm trying to find out what 1 penny gives me. And when I divide the other side by 80, I get 3 grams per penny. So the bar that gives me the best value is the large bar, because I get 3 grams for my penny as opposed to the small bar, which gives me 2 grams for my penny. Last one on unitary method and best buy for you to have a go at. A large tin of tuna weighs 450 grams and costs 90 pence. A small tin weighs 200 grams and costs 50 pence. Which tin is the better value? So we've got the large tin, 450 grams at 90p. So our large tin is a relationship between grams and pence, and it's 450 grams for 90 pence. To work out how much we get for our 1 penny, we divide 90 by 90 to give us our 1 penny. And if we divide one side by 90, we need to divide the other side by 90. So we get 5 grams for our penny. For the small tin, we have a relationship that tells us there's grams and penny, and we get 200 grams for our 50 pence. To compare like with like, I'm going to force this to be the number 1 by dividing it by itself. 50 divided by 50 gives me 1. What I do to one side, I do to the other, and 200 divided by 50 gives me 4 grams. So I'm getting 4 grams for my 1 pence on the small jar. So the large jar is the better value. Another place you come across unitary method in practical situations is maps and map reading and scale drawings. Now we'll come on to this later in the course. So for now, all you need to realize is that when you see a ratio on a map that's 1 in 25,000, or that 2 centimeters is 1 kilometer, depending on what the scale is, or 1 in 50,000, these are merely strap lines for your ratio. So to go from the real world to our map or our scale drawing, we need to put the value under the correct side. Now you're going to get lots of practice on this later on in the course, but it's simply a unitary method where you're given one of the parts. So let's just give you an example to show you how straightforward it is. The scale on a map is 1 centimeter to 2 kilometers. So what we're talking about is our map to the real world. They're the two things that we're looking at. And I'm telling you that our map is 1 centimeter, and that's equivalent to 2 kilometers in the real world. So when we've got a scale drawing or a map, we just set up our strapline for our ratio depending on the relationship between the map or the scale drawing and the real world. Now, it's telling us that on the map, the distance from the campsite to the nearest beach is 6 centimeters. So it's a parts ratio where I'm telling you what our map reading is, and that's 6 centimeters, so it lives under here. To get from centimeters to centimeters, how did I get from 1 to 6? 1 divided by 6 means I multiplied it by 6. What I do to one side, I do to the other, so I know that the real world is 12 kilometers. So the actual distance would be 12 kilometers. Have a go at this one just to see how straightforward converting scales are. So a plan for a new garden has a scale of 1 inch to 6 feet. So our drawing is in inches, and that's 1 inch, and the real world is in feet, and there's 6 feet. So 1 inch on my drawing is 6 feet in the real world. The length of the pond is 3 inches on the plan. So on our drawing, our plan, we've got 3 inches. How did I get from 1 to 3, I multiplied it by 3. Our scale, what you do to one side, you do to the other, means that our real world pond will be 18 feet. So in the real world, it's going to be 18 feet. Another place you come across where you use ratios in a practical way are measures, and for example, converting metric and imperial units. So for example, if I told you that 1 kilogram is the same as 2.2 pounds, I'm giving you the strapline to something before we convert it. So for example, if I wanted to convert something from kilograms to pounds, I would use my strapline that I've been given there, my relationship of 1 kilogram is 2.2 pounds. So for example, if I said I bought a chicken and it weighed 5 kilograms, the 5 kilograms would go on this side because it's a parts ratio. To get from 1 to 5, I've multiplied by 5, and what I do on one side, I do on the other. So my 5 kilogram chicken actually weighs 11 pounds. The final way we're going to show you a use of unitary method is what we call compound measures. Now, when I gave you the example earlier of ratios, one of them was, for example, miles per gallon, MPG, the P standing for per. Now, per relates to something that is the number 1. You're going to force something to be the number 1. So in this instance, miles per gallon is telling you that my car can do 40 miles per gallon. The gallon is the number 1. Now, using that strapline, I can either tell you how many gallons it takes to do a number of miles, or how many miles you'll get for a number of gallons. I've created a strapline, and I can use the part that I'm interested in. So for example, let's just say I wanted to do 320 miles in my car. How many gallons would I expect to use? So if I'm telling you I want to do 320 miles, it's a parts ratio. I'm giving you the number of miles. So 320 lives on this side. How do I get from 40 to 320? Well, divide 320 by 40 and you get 8. So my scale is 8. If I multiply the other side of the ratio by 8, it tells you I'm expecting to use 8 gallons of petrol to do the 320 miles. Now we're going to do compound measures in the next week's lessons, but I'm showing it to you because compound measures are essentially ratios. And that completes our learning outcomes for this session, to identify ratios and proportions in practical contexts and solve practical problems. Our buzzwords for this session are unitary method, best buy, and compound measure. Unitary method is where we can look at something with the value of 1. We force one of our parts of our ratio to be the value of 1. And one of the most common places you come across this is exchange rates. Best buy is where we have 2 or 3 things we're trying to compare, and again we force one of the sides of our ratio to be the number 1. So when we had our large jar of jam, we could work out how much we get per penny, and then the small jar we could work out how much we get per penny. And because we're comparing it per penny, we can compare like with like. It tells us what the best buy is. And then finally, compound measure, again, is using the unitary method where the word per will be used with your compound measure. So it might be something like £40 per hour. So if you have pounds and hours, it's 40 to 1. So the word per is forcing your ratio to have a value of 1. And from this point, from this strap line, you can work out how many hours you can get for the money or how much money you need for so many hours. And we'll cover that in a bit more detail in next week's lessons. And that concludes this video. If you have any questions or you'd like more practice on anything we've done, please have a word with your tutor.